I've got your two rules up here. We're going to work the ratio test first. I just wrote both of them up here at the same time just because they have the same, this part down here is the same divergence and convergence. So what we're going to do, in each case, we're going to take a look at a limit. And we're going to get a value. I don't know what value we're going to get. If we get a value larger than 1, it diverges. If we get anything 0 up to 1, converges. If we get a 1, we wasted our time. Neither test works. And you've seen a limit show up as 1 before. It's not a big surprise. Okay. So if we end up with a 1, it doesn't work. Ratio, fraction. Fraction. Okay. M plus 1 term will be on top of the nth term. Create that fraction. Root. Okay.
That kind of confused me, glad you explained it.
It was rough. Okay. So we'll look at kind of some differences and stuff. This guy here, the ratio test, it takes a little longer than some of the others, but it's usually one of my favorites because it works most of the time. And when we start doing some power series and stuff next week, we're going to have to use it again. It comes back again. So it ends up being one that becomes a little bit more familiar. Things like that. Root test. We're going to use the root test when we actually see an nth power. So think about this. We'll get to one in a minute, but an nth root would cancel out an nth power. Just like a square root would cancel out a square, a cube root would cancel out a cube, an nth root is going to cancel out an nth power. See some things like that. So let's look at the ratio test first. We're going to do the ratio test, or ratio on these first few. Sum as n goes from 1 to infinity, negative 1 to the n over 2 to the n. So, now again, you might see some things on some of these that you're thinking of an old test that we did, something like that. Absolutely correct. We're just going to practice our ratio test. We get practice with the different ones, okay? Like, for example, you can see it's alternating that we just talked about. Okay? We're going to practice that ratio test, so we're going to look at the limit as n goes to infinity. Now, it's the absolute value, so do I really need to worry about that negative 1? No. Oh, it would be gone, right? I don't care if you had an m plus 1 or an n, it's still just going to be a positive 1, right? It's not going to change anything. So for the sake of this, I'm just going to leave it out. So I'm going to have m plus 1 over 2 to the m plus 1 divided by n over 2 to the n. So again, back to our rule here. Take our limit to infinity. The n plus 1 term, that just means we're substituting n plus 1 for the n's. Okay. Divided by that nth term, which is just the original one. Yes, technically, you've got a negative 1 to the n plus 1 up top and a negative 1 to the n on the bottom, but it's the absolute value, so they're not going to matter. So I just didn't bother writing them. But they are in there. So this will be my setup. I've got to evaluate this limit. This limit looks like kind of a pain because you see that complex fraction. Whole thing's a fraction, one up top, one on the bottom. So what I would suggest is go ahead and rewrite it with the invert and multiply. Because we don't divide fractions, we invert and multiply. And if I have a fractional piece that I'm using in my ratio test, most of the time for me, I usually skip this step. I just go ahead and invert the bottom one. Okay? That's up to you whether you write this one or not. We're going to end up switching it after anyway. Right, so the key is now I've got to evaluate that limit. Now remember our exponent rules. This guy down here is 2 to the n times 2. Or 2 to the n times 2 to the first, right? I don't really need the 1, but it's 2 to the first. Well, now that means that the 2 to the n's cancel. Leaves me a 2 on the bottom. Now, at infinity, would the n plus 1 and the n cancel? Yeah, because that's just going to go to 1, right? It's not going to change anything, so they cancel. That means my limit value is 1/2.
That's not one.
No, it's not 1. Is it bigger than 1?
Yeah.
No.
It's less than one.
That's less than 1?
Series converges.
Converges.
So which? Can it be greater than one?
And it diverges if it's greater than 1.
Oh, right. What happens if it's? Oh wait, never mind.
So the other nice thing about the ratio test is you're already used to doing limits. You've done a lot of limits, okay? I'm not going to say every limit that you do is an easy one, but it is at least a familiar process for you. Right, working with those pieces. Okay, now let's take a look at this. Let's switch it up. And let's go, n goes from 1 to infinity, 2 to the n plus 5, over 3 to the n. And again, I see those numbers to the end. Yeah, a lot of time we're going to practice our ratio test here, but you kind of see, you should recognize kind of a geometric there. Seeing something like that, the 5's not going to matter at the end. So let's put it into the ratio test. Limit. N goes to infinity. Absolute value. Are you okay with me switching to go ahead and multiplying by the reciprocal?
Yeah.
Okay, so we're going to go 2 to the n plus 1 plus 5 over 3 to the n plus 1 times 3 to the n over 2 to the n plus 5. Now we're at infinity. So if we're at infinity, what really doesn't matter if they're all? So the plus 5s, right? Okay. You can add 5 up here, add 5 down here. It's the same amount being added. They're going to cancel out. But quite frankly, if you're adding 15 here and 5 here, it's still not going to matter at infinity. It's just a constant. So my focus is going to be on those powers. This one's 3 to the n times 3. And this one is 2 to the n times 2. So I'm not worried about this guy at all. And again, I'm not really worried about those 5s because I'm at infinity. Infinity is going to take out those 5s. So now what cancels? Okay, 3 to the n's, 2 to the n's, 2/3, less than 1, converge. Pretty okay there? Okay. Still ratio test. I'm going to bring back in one of those factorials we've seen. Let's go with the sum. N goes from 1 to infinity, n to the n over n factorial. So my limit is n goes to infinity, the n plus 1 term over the nth term. I'll write it out and see what I've got to work with. Limit, n goes to infinity. All right, the n plus 1 term, n plus 1 to the n plus 1 over n plus 1 factorial. So remember the n plus 1 term, n plus 1 is just replacing n in each spot. Now we're going to divide, but multiply by the reciprocal of the original. All right, what are some thoughts? What can I do there to kind of simplify that a little bit?
Factorials are going to cancel.
Completely?
Not all the way, but they're going to cancel the 500.
All right, factorials will simplify. So we can rewrite this as n plus 1 times n factorial. So it'd be n plus 1 times n minus 1 times n minus 2, so on and so forth. That would be n minus 1, n minus 2, n minus 3. And that's going to take these two guys out. Leave me an n plus 1 down there.
You can split up the n plus 1, the top 10.
Okay.
To the add an n plus 1 first and then cancel.
I agree with that. We can split this up. n plus 1 to the n plus 1 to the first. And then the n plus 1's cancel. We like that? I agree. All right, now let's take a look at what we've got here, because we've got those exponents that are kind of screwing things up on us a little bit. I'm just going to rewrite this. Limit n goes to infinity. N plus 1 to the n over n to the n. Now I'll put the absolute value up there, but at this point that's not going to matter anyway. Everything's staying positive. We know that. Okay. Now those don't cancel, because that 1 can change some things as far as the power, but let's look at putting them the same. We're going to see something familiar here. How about n plus 1 over n to the nth? Now if I'm thinking about an infinity, this would be infinity, be 1 to the infinity, right? That's an indeterminate form. Right, so that means we've got to mess with it a little bit. Now, there's some things we can do here. You should remember using logs and things like that to bring the power down. But what if I rewrote it like this? 1 plus 1 over n to the n. Remember what that is? That's e. That equals e, which is e to the first, which is greater than 1. Diverge.
Oh, because it's n, 1 over n to the n.
Yeah. So remember how we saw before, I think we saw this once with a k. Right, and it became e to the k. There was a 2 there, it's e squared. This is what we looked at before, where that compound interest formula became the continuous one. Went to that e. It's going to be a good thing if you can try to remember that's an e. If you don't, let's investigate how we did it. So I'm going to erase this and just investigate that piece there. We got it set up. So remember, this is what we did. Limit n goes to infinity. If I did not know, I just called it L. Got to figure out what the limit is. We wanted this power down. That was the problem. So what we did was we took the natural log of both sides. That let the power come down. N goes to infinity. N, ln, 1 plus 1 over n. That becomes infinity times 0. Indeterminate form. We need 0 over 0 or infinity over infinity to use L'Hopital's rule. So we switch to this. ln 1 plus 1 over n over 1 over n. Okay, now that's giving me the 0 over 0. Still equal to ln of L. 0 over 0, we took the derivative. And 1 over 1 plus 1 over n times derivative of the inside, negative 1 over n squared over negative 1 over n squared. Those cancel. Now as n goes to infinity, that's 0. Plus 1's 1. 1 divided by 1's 1. Still equals ln L. So L would be e to the first. That was the proof we did before. and still works fine if you go back through it over and over and over. But it is nice. We've seen this a few times. I'm not saying we remember it perfectly, but it should sound familiar. And what we're going to see is this guy's going to change right here. And as it changes, it's just affecting that power.
How do you get from the n plus 1 over n to the 1 plus 1 over n again?
Just split it up. So you have this fraction n plus 1 over n. So that'd be n over n plus 1 over n.
Okay.
If I split up the denominator because I have that single denominator, that's where that's coming from. Are you okay there? A couple different looks. Okay, let's look at the root test. The root test, when I typically want to look at the root test, it'd be something like this. Let's go sum, n goes from 1 to infinity, negative 1 over n to the n. So a root test typically used when I see that nth power, because that's the problem I'm having. One of the problems I'm having, I've got an n up in the power, I can't really deal with that. That's going to put an infinity in the power, and that's where the problem is. Okay? So if you substitute infinity here, you're looking at, 0 to the infinity, and that's kind of messing things up.
Would that be just 0 times 0 times 0 infinite number of times?
No, because that's not really 0.
It's almost 0.
It's almost 0. That's where the problem's going to. So I agree. 0 times 0 times 0 is 0, but remember this, we're saying it's approaching 0. That wouldn't actually be 0, and that's what's really screwing things up. Okay? So, the root test. Okay, the limit is n goes to infinity. The nth root of the absolute value of negative 1 over n to the n. And in this case, you can kind of see, like before, all that the absolute value is going to do is take out the negative. It's going to eliminate that piece. The nth root of the nth power, that would cancel out. So this would really be the limit as n goes to infinity of 1 over n. And then technically it's still the absolute value, but that's not going to matter because I just took the negative out of there. So what's this limit as n goes to infinity?
It converges.
0.
0 converges.
Converges.
Let's go over.
So again, greater than 1 diverges, equal to 0 up to 1 converges. 1, wasted time. So this one's going to converge. This one, let's go n equals 1 to the infinity, 2 to the n over n squared. Now the root test, that nth root is going to help me get rid of that nth power. The squared power doesn't really bother me. I mean, it's just a basic square. I know what that is. Okay. The problem is I don't really know what an nth power is when it's going to infinity. This would still be an absolute value because that's what we're doing inside the radical. I think logically I can't take the nth root if it ends up being, if n is even and it's negative, that's why it's got to be absolute value. You end up with imaginary. I don't really have to worry too much about that here because there's no negatives in here. But I'll still write it like that. So I'd have the nth root, absolute value, 2 to the n over n squared. And that nth root, remember that's kind of a, think of it as a 1 over n power. So, just kind of reminds you of your old exponent rules. That's really to the 1 over n on both of them. Okay? So power to power you multiply, so this would be the limit. N goes to infinity 2 over n to the 2 over n. Everybody okay with that? So the top, that's obviously 2. There's nothing to do there, right? Going on. What do you think about the bottom?
Well, that's going to be infinity to the 2 divided by infinity. 2 divided by infinity is 0. So that's infinity to 0. No, that's going to be an extremely
Split it into your powers.
Very
of
close.
one.
2 over 1. Exactly.
Can't split it because it's division.
But yeah, but I'm saying like if what you get, I think the nth root of n squared.
That just be
What sort of?
That doesn't help though.
really.
That wouldn't change anything. I mean, it is the same thing though. The nth root of n squared. I like what you said, Robert. You didn't finish it. What's the value then?
Wait, hold on. But infinity is anything raised to the 0. Well, this isn't quite 0. It's really close to 0. But that was 1, right? So it would be 2 over 1. Wasn't really wrong.
Yeah. Well, what is it?
There you go.
Thanks, bud.
You're hitting that 0. So you're right. It's not 1. It's approaching 1 though. So it's approaching that value. And so that would give us 2. That's greater than 1. Diverges. We okay there?
A lot easier than
And this is one that with these two different ones, a ratio test would work really good here. Something like that. Because they're not both to the end, but we were just practicing the root test. You can kind of see. Everybody okay there? So again, same thing on the homework. Even if you see something else, if it asks you to do the ratio, do the ratio. The root, do the root. So you get the practice. Okay? When we roll around, start reviewing and things like that and tests and stuff, it's not going to matter, but you need to practice with each one. Okay? All right.